Hey guys. So today in this session we are going to discuss how we can test React web apps using Chai and Enzyme. So I'm Bhargav. I'm a full stack web developer. I work mostly on React.js and AngularJS these days. Besides the front end technologies, I also work on Android, Node, and Play framework. Right. So in this session, firstly we are going to discuss why we need to test React web apps, and then we are going to understand the roles of Mocha, Chai, and Enzyme in testing. And then we're going to get to the code. So towards the end of the session, we are going to be able to build a web app which looks like this. As you can see, we have a search box which is able to filter elements in a list. The web app in itself is quite simple, but we are going to have a look at how we can test the components, how we can test the search utility, and so on. Right. So why do we need to test React code? So we need to test any sort of code because unintentional bugs are almost found immediately. So unnamed exports or a return statement which is faulty. So these bugs are caught almost immediately, and it also saves development time because you could only worry about the features and behavioral bugs. So how do we test a React component, React web app? So a basic React web app contains three parts: the components, utils, and everything else. So assuming that we are not using a framework like Redux or Flux, which has so many more modules in it, we are using a simple React web app here, and we only have essentially three parts. The components and the utils are the ones which are testable, and the rest is the JavaScript which binds the two other parts together. So let's take a quick look at the tools that we're going to use. The first tool is Mocha. It's a test environment in which all our test cases are going to run. So our global variables are created here. The heap is created here, and all your tests are structured here. So if you can see, if you can have a look at the code on the right, you see that there is a describe statement, which is essentially just splitting your tests into multiple suites. So you have a root suite, and you have component tests, util tests, and other tests. So this is how we are going to structure our test suite. Mocha is also able to evaluate assertions from libraries like Chai. So Chai is an assertion library which just tells Mocha whether a test has run or not, or whether the test is successful or not. Mocha is also able to highlight errors in test cases and able to tell the user what is the expected output and what is the actual output. And Mocha also has an interesting watch option which allows you to continuously run your tests in watch mode. So whenever a code changes or whenever your test case changes, Mocha runs in the background and reevaluates your tests. Right. So next we'll move on to Chai. Chai is, like I mentioned, is an assertion library. The if statement which you see in your test cases is essentially where Chai comes into the picture. So in this code, it's just a pretty simple test where Chai just expects a number 1 equal to 1, and this is obviously going to pass. So we are going to use some advanced kind of assertions here and test our React components. The last tool that we are going to use is Enzyme. Enzyme is a tool specifically written to test React components. So Enzyme has a function called mount, which mounts your React component into the Mocha environment. So if you're wondering how Mocha is able to actually behave like a browser, it's possible because we are using a library called JSDOM, which mimics your browser. So it's like you're running your React code in a browserless environment, yet it has all the features of a browser. So let's get started with the code. So what we have here is, we have all our JS files in our assets. Sorry guys. Okay. Anyway, so this is our JS folder. We have all our application related assets over here. We have an app.js file. We have an index file, which is just a simple root component, which stores our main component, which is the app. Guys, there is a lot of disturbance. Someone's audio is on. Right. So we have a JS folder here in our assets, which essentially contains all of our application logic. Index is the root component, and we have an app component, which is sort of the main component where we have a search utility and the list view. Then we have a list view component here, which just takes in a list as a prop and just renders the list items. And then we have a search utility over here. Right now it's not functional. So, right. So this is where all our test cases lie. So towards the end of the session, we should be able to make each test case run. So if you have a look at the test cases, we want our search input to correctly set the state of the app component. We want a list view to correctly render the elements, and so on. So essentially, we just want our components to behave exactly as they're intended to. So let's start with our search utility. Just a second, let me run my code. NPM start. Right. So we have a search box here, and this search box happens to be an input inside our app component. And what we would like to do is, when the input changes, we want to set the state of the query variable to whatever the value is inside the input component. So let's do that. So we have an onChange function here, which triggers the handle change here. And we are going to set state query to e.target.value. Right. So this should set our state. The next step is to enhance our search function. The search function is taking an array and it's just returning an empty array. So what we are going to do is we are going to filter our array with the query. I should include the query. Right. So in case you're wondering what before each is a utility provided by Mocha. So what it does is, so we have two test cases here, two test cases which are going to be run by Chai, and they are both going to use list in the assertions. So we don't want to use the same list in both cases. So what we're doing is we are reinitializing list with a new array so that unwanted mutations are avoided. So, so the first step is to check if search utility is defined. Let's run our tests here. Yeah, so search utility is defined. So we are importing search from our utils folder, and it's definitely not undefined. The next step is to see that it filters a list correctly. So expect search dot search takes two arguments, which is an array and a query. The array here is list, and let's take the query to be code. and this has to have a length of 1 because code is only present in Codementor. So this should the size of the array which is returned should have a length of 1. Let's remove the skip here. Right, so that's passing as well. Now let's also try with Google. So what happens if you set geo here? It's failing because our search is not case insensitive. So we have to change that as well. So let's set this back to code and create a new test case here saying a search, you should filter a list correctly in a case insensitive fashion. So to do that, we're going to pass go, and here we'll just change our function. We're going to convert every list item to lowercase first and do the same thing to query as well. So now this is also passing. So our search utility is working perfectly fine. Now let's go ahead to our list view. So we want a list view to correctly render the exact number of list elements, which equals the list item which is passed. So if you're passing the list as an array of 4 integers, it should exactly have 4 elements as the li elements. So as you can see, the list view accepts list as a prop, and it's going to map over the list and create li elements corresponding to each list item, and then it's going to render it. Right. So wrapper is already defined, which has our list view. Expect wrapper, which contains our list view. Dot find. So Enzyme has a function called find, which allows you to identify either a class or another child component using this function. So you could search for all LIs using this selector, and you want the length of this to equal 4. To dot have length of 4. So that's passing as well. The next step is so the idea here is that we want to, before we actually render our list view component, we want to make sure that it passes all the tests, and then we'll go render our list view in the app. So we want to follow this approach because this is truly test driven. Unless a component actually passes all the tests, we're not going to render it in our app. So now we want to check if the text set in the li elements is exactly what we expect. So let's find the li elements here, and at index 0, we want its text to be or to equal. The text in this case is 1, but since 1 is converted to a string, it's going to be okay. Just keep running here, right? And we also want our list view to have to show a loading kind of to show a no results kind of a container when there are no list items. So let's add that feature as well. But before that, we'll write a test corresponding to it. Expect wrapper. Okay, for this we need to create another wrapper. Since this wrapper has a list element which has 4 elements, there is no way that no results div is going to be shown. Let's create another wrapper. Let my wrapper equals mount of list view with a list argument with no members, right? And we want my wrapper dot find. So we want to find a div with class no results when the list has no members. Dot to have length 1. So this is failing because we don't have a no results div in our list view. So let's go ahead and do that. So what we're going to do is we're going to add a condition saying if list dot length is 0, then return a div with class list view no results. And some test saying no results. Right. So now our list view is complete as well. So now let's go ahead and complete our app component. Or before that, let's see if our list view is rendering correctly. List view list equals list. So we are using the same property which the app component is getting from the root. So in this case, the app is receiving a property list from this object called cities, and cities happens to be just a huge list of Indian cities, right? So app has received the prop, and we are passing the same prop to list view as well. We could have used something called React context in this case, but for the sake of this session, we are just going to go ahead and use a prop. So list view has the list prop set, and there you go. You have your list view populated. The search view is not entirely functional. We need to change that. But yes, your list view is working perfectly fine. So now the next step is to make sure that when a key down happens, we want to check, we want to change the state of our query and use that query to filter, to search for the list items which satisfy the condition that the query string is a substring of a list item. So to do that, we already have a search function which is completely tested. We are going to create a new list saying filtered list items or filtered list, which uses a search utility, takes the list as the first argument and query as the second. So now that this is done with, we'll pass filtered list to our list view. Right. So let's go ahead and check that. Okay. Great. So now that our app is completely functional, let's go and add a couple of more tests to make this even more robust. So Enzyme also has a couple of utilities to test on-change event as well. So if you have seen the app component, what we're doing is we are checking for the on-change event, and when the on-change event happens, we are triggering a handle change component method, and that is doing a set state that is calling a set state function. So what we could do is we could simulate our on-change event and see if this function is triggering our state correctly. To do that, let's go to our test. So we already have a wrapper. Right. So first we're going to simulate the test event. So to do that, we're going to find the input which has access to the click event, which is within the class named search. Wrapper.find.search, and the input within search, and simulate So simulate is also a function provided by Enzyme. Simulate an on-change event with the event argument being a dummy argument which we are setting. And since we are accessing event.target.value, we need that value to be set. So let's just set that target value is hello. Right? So now this is set. Now let's check if this is setting the state correctly. So wrapper dot state dot query should equal hello. Expect query to dot equal hello. Right. Let's remove the skip here. Oops. Try something. Wait a second. I think there is an on-change event. Oh, it's changed. Sorry. Oh, my bad. On change. Right. So yeah. So what we're doing here is we are mocking a change function on our input element, and when that happens, we are just checking if the state is being set correctly. And in our case, it's working. So in our test so far, what we have done is we have written unit tests. So we have written tests for our ListView component, we have written tests for our app component, but let's go ahead and write an integration test, or sort of a pseudo integration text, where we check if the simulate event actually changes the list view as well. So it's sort of a combination of multiple tests. Our first integration test. So we have created a integration test suite. So we want when a change event happens, the list view correctly gets the list prop function. Right. So let's go ahead and create a wrapper. So instead of going for app, so instead of going for list view, we are directly going to mount the app as a whole. Wrapper is equal to mount app with a list view with a list. Const list equals right. So wrapper.simulate .find.simulate change, and we are going to pass the same e.target.value here again. Target dot value equals code. And since code happens to match Codementor here, we should find a list with size 1. So wrapper.find list view. So find is also able to find out a React component. So we have already seen how it works in a jQuery kind of selector syntax. It's also able to take a component as an argument. So wrapper.find list view is going to get a list view, and it needs to and we are going to find the li elements within it, and we expect its length to be equal to 1. Expect dot to dot have dot length of this 1. Yeah, so this is also working perfectly fine. Right. So I also wrote a couple of tests which might help you. So one test is you could create a for loop kind of a thing in Mocha as well. So instead of writing test cases for each of your components, you could put all of your components in an array and render and run tests on them. So you could do something like this. Right. So what we're doing here is we have an array called a tests which contains two objects. One is the app. One contains the app component. The other contains the ListView. We are creating name keys as well, just to show the right kind of output in our console. So what this test is going to do is it's going to iterate over your test object and just going to print. In the case of app, it's going to print app correctly takes foo as prop with value as 10, and here test.component happens to be app. So yeah. So what we're doing here is we're just testing if the React component is taking the props and is the value being set properly. I see. So the problem here is that app expects a list component. So when you didn't supply, it's throwing an error. Let's change it to list just to make our test cases work. Whoa. Oops. What? Oopsie. So for some reason this is failing. Anyway, let's enhance our app a little further. We'll create a test case from scratch, and we'll try to paginate our app a little bit. And instead of showing so many results here, let's paginate it. And before actually paginating, we'll create our pagination test suite. So to do that, pagination test suite function. It before we do that, I think we need to create a pagination utility. Describe pagination utility. It is defined. So our pagination is going to take total results or total count, the current page being viewed, and page size. Right. So Yeah, we expect pagination utility to be defined. So expect paginate to dot be not undefined. Let's input that here. Right, pagination utility is defined. The next step is actually passing props to it. So what we expect is if the page size is 10 and if there are total of 90 results, then we need 9 pages. And depending on the current page, we want to output the previous page, the next page, and the current page in our navigation bar. So let's do that. So describe when page size is 10 and total results is 100 and current page is 1, or let's say 5. Correctly displays. Sorry, it's so long. Function so our paginate utility takes an object. Let options be an object which has total underscore count is 90, page underscore size is 10, and current page is 5, and page is 5. Right, so we are going to pass this to options. Sorry, we're going to pass this to paginate of options to null can't be null anyway. Expect paginate of options. So we want to, let's return the same object for now, or let's skip this test. Let's first finish our utility and come back to it. So right. So if the current page is greater than 0, we are going to have next and previous. Let's declare our buttons, our pages. Next page, current page is already there, then previous page. If page is greater than 0, the next underscore page is defined. Sorry, previous underscore page is -1. Since there is sorry, page equals 0, there is no previous page. If const maximum pages is equal to mat.ceil of total count by page size. So this returns the maximum page possible. So if there are 91 results, then this is going to return 10 as the output, right? So if our current page is equals max pages, then there is not going to be a next page. Otherwise, next underscore page equals page plus 1, previous underscore page equals page minus 1, right? So we are going to return an object which has previous page, next page, and page. Right, so let's just test this. So if these are our options, then we expect the output to dot equal Oh wait, I think it's just a second. Mhm. Yeah, sorry. It was anyway. So now that this is working, so now we also want. So when our page size is all of this is the same, and when you only have when the current page is 0, you want your next page to be defined, which is 1, your previous page to be -1, and your current page to be 0. Right? Oops, sorry. Yeah. Um, and when the current page is 9, which is the last page, since we are 0 based, and current page is 9, we want our next page to be -1, our previous page to be 8, and current page to be 9. This will fail because we are over here. We are going for math.ceil, which gives 10, but this should be 9. So yeah. Could you be equal? So actual is 10 and expected is -1. Okay. The current page is 9. Total count is 90 and page size 10. So 90 by 10 is 9. Oh, sorry. The condition is obviously wrong. Page size has to be 8, right? Sorry about this, guys. Next page is 9. So 90 by 10 gives us sorry. The correct output is 90 by 10 is going to give us 9, and our page is 8. So this should work. Guys, am I missing something here? Sorry, 90 by 10 is 9, which is our max page size. So okay, I'll stop here. I'll come back to it a little while later. But someone has requested me to talk about the setup as well. Anyway, I'm not able to debug this issue right now. So our this is a package.json file. We have since ES6, since transparent to ES6 has a couple of issues, we are using add model express plugin as well. But looking at our test utils, we have Chai Enzyme. We have JSDOM, which actually serves as our browserless environment. We have Mocha, which is our test environment. And React add-ons test utils is something that Enzyme needs to function. I'm sorry, we don't need this. And coming to the setup, we have so Mocha needs a setup file, which is mocha.ops. So here we are going to pass, we are passing a compiler option here saying that our test cases are written in ES6. So we need Babel to actually compile it. So it looks for the extension JS and transpiles it into ES5. So we have a file called mocha helper.js where we are declaring our globals. So that's over here. So the setup that I mentioned earlier, so we are using JSDOM here. So before React is actually required, what we have to do is we have to create our JSDOM environment within Mocha. And we are going to create a dummy document, which is going to behave like a browser document. And we're going to have a window object, which is, so these are a few steps which will allow you to instantiate your JSDOM with a set of global variables, which React expects. So then we are going to create our globals. So instead of just having documents within your Mocha environment, we are going to create them as global so that whenever React is required somewhere within app or somewhere, it's going to check for the React which is loaded inside Mocha. Yeah, so that's pretty much it. For some reason, I'm not able to debug this issue. So I thought I had plenty of time left, so I wanted to try something else. Yeah. So if you guys have figured out what I'm missing here, I'd be happy to learn. Yeah, so that's pretty much it. So some tips. So when you're in a time crunch, that ensure that you cover your utils completely. So this saves you a lot of time. Generally, what I do is I don't entirely test my React components. What I do is I ensure that all my my utilities like search, page init, these are completely covered. When you're testing Ajax calls, you could use a library called knock, which helps you to mock an API call and serve a dummy response, so that it will serve as a fixture for your promises. And then you have Synon.js, which helps you to test component measures like component did mount, render, etc. So what Synon does is that it has a utility called spy, which injects a dummy function instead of component did mount, and you could check using Synon's built-in functions if that was called or with what arguments it was called, and so on and so forth. Right. So thanks, guys. You can find me on GitHub and Codementor and LinkedIn here. I'm going to put this repo on GitHub, and I'll try and fix this out. Not sure what I might be doing something very silly here, but Yeah, once I fix this, I'll upload it up to GitHub and share the link on Codementor.